Hello everyone, welcome to the another video in Rust programming tutorial. In this, we are going to discuss about the enums. So we might have heard this and we might have known this concept from the other programming languages like C and C++ languages, right? So basically, enums are like some set of values, like it is a kind of user-defined data type where we will give like some allowed values within that particular enum. So let's take, for example, we have something like enum flight. What flight will contain like some seats which are of economy class, business class, and first class seats. So the values will be same like economy, business, and first. So those will be like the economy value is can be 0, business value will be 1, first value will be 2. So it's like a descriptive name so that we can use it in our code, okay? So basically, we can simply define them like the first letter in the enum name will be capital, and we will give the all other allowed values with the capital letters. Okay. So like in Rust, these are like extremely used both in the Rust library as well as the code that we write. So enums why we are discussing now is because in the coming videos we will be using the enums for the error handling and other stuff. So that's why we are discussing the enums now itself. Okay. So let's take for example this. I have already come up with a code and this project is created with a cargo. So for now, let's see this particular enum color. Okay. So in this, we have given the primary colors like red, green, and blue. Okay. Now we have one function. So the demo simple enums. So in this, we are taking like let's see color. So we are saying like its data type is color. That is enum. So and we are assigning the red value. So we already discussed match, which is just like a switch case in other programming languages, which will be matches with the patterns. In this, you see that the red, green arms are extended for the so and so print statements. Okay. So, okay, actually we no need to give this one because it can infer its data type. Okay. So now we are assigning the color red and then we have green, blue and other things. Okay. So this is like whatever we have in the enum, all the three we are giving. So while if you run this, we may get some warning like it is a dead code, like why we are using a green and blue. Those not using, we just have the enum, but we do not have that, right? Because we are only used red. This is like a match, but it is not kind of uses. So to avoid this, I think we already aware of that, like there are some compile time attributes, those we can add. It will be like this. Yeah, this is like a compiler attribute. We are telling that just allow the dead code. This is actually not recommended since we are our example to explain we should need this kind of situation. That's why we are adding. Otherwise, it's not recommended to use this one. Okay. So here we see that the color red. If it is a red, we are saying like a Coke. If it is a green, we are saying like a grit. If it is a blue, we are saying like a glass. Okay, now since we have given the value red, so it will go into this particular arm, Coke arm. Okay, now let me use this cargo run to execute this. Yeah, so we can see that. So it is executed like a demo, like a simple enums. It's extended like pattern is matched with the value red because we are giving red. So because we know that the value is red, but we are giving for other three values also. What happens if you comment out one of them? It will give the warning like it's not the exhausted list. This is not the complete possible list of match. Okay, it's give error. Okay, so you can see what it is saying like ensure that all possible cases are being handled. So this is not an exhaustive list. So we have other way of doing this. If you remember, like we have something like underscore. If you give underscore, it is like anything other than red, it should be going into this particular thing. Okay, so we can say like who cares, if it is red then only print it, otherwise we don't care. So this one will work, right? So because we are still giving red, so it's went into this one. We didn't give any warning or error. Let's say if you give blue, it goes into the default case. You see this, now it's completed the execution. We see that it's went into the who cares. Okay, now we have seen this simple enum how it works. Now we will go into the further one, enums with data. Okay, so for now I will comment out this, I will comment the other function, and I will uncomment the other function. Okay, now let's take another enum which is like a house location. So the house location can be either a number or name of the house. Like we will generally have numbers for the house as well as name for the house, or maybe you don't know the house location. Okay, so these are three possible scenarios. So the number will be like a I32, name is a string, and the unknown case. Okay, so now this example is with the demo enum with data. Okay, so basically let h house location will be number 4. So we don't need to use this. Actually the rest can infer the data types, it can understand what kind of data type it is. So now let h equal to house location number 4. So again with the match case we are doing this like if house location colon colon, if it is a number then it is like lives in the so and so house number we are printing. If it is a name we are printing like so and so particular this one like name of the house, and the unknown case the house location is unknown. So here basically we should have the data type which can hold our size like the complete data. So the house number should be able to hold by the I32, and the string should be held by the like the string is like nothing but collection of characters, right? So so that we are printing size of the house location in terms of the bytes. Okay, this is how we will find size of the any variable. Like we will get the namespace mem and size of, this way we will find out the size. Okay, now let's execute this. So before executing, let's say for example if we give number 4, then it will fit into this particular case and it will holds this. Okay, it will not go further and check it. Okay, like this. In case if you are passing the string, it will go and hold fit into this name string. It will extend its pattern to the live in the house named so and so, we will it will print. Okay, now let's execute this once. See this, you live in house number 4, the size of the house location is 32 bytes. So the overall house location enum size is basically 32 bytes. If you wanted to pass the string, how do we pass the string is like a string colon colon from of Hyderabad. Okay, you see this, you live in house named Hyderabad. Okay, so what if you are not giving anything, we just mentioned unknown. Example, you don't know the house location, so that you can give like this like unknown, so that it will went into the last case like your house location is unknown. Okay, now let me execute this. Yeah, you see this, your house location is unknown. By the way, size of the house location is 32 bytes. Okay, but this is like example enums with the data. Okay, now as of now we have discussed like it is our own data and it is our own enum. Okay, so it is not a inbuilt enum, it is like a user defined enum. Now there are two enums which are actually the inbuilt enums that we are going to discuss, and like those are most useful and we will use most of the times. Okay, so for now I will just comment out this code. Okay, it is like a demo using the option enum. So Rust defines this standard enum like option of t. So basically the enum looks like this. So enum option, the value either true or false, so that it will go into the sum or none case. Okay, so this is a inbuilt one. So now we will see how it works. Okay, so let's see, take like favorite number option of I32, and we are assigning like favorite number equal to sum of 3. So the match case is like this: favorite number sum of n. So here you see we have not defined anything. We are just mentioning like option of I32. Okay, so that it can infer that it is like a this particular option enum. Okay, so now here you see println your favorite number is so and so, and it's a good choice. If you don't know, dude, you don't have any favorite number, what like here saying like it's like surprised you do not have any favorite number. Okay, so now you see we are sending 3, and it should go into this particular case. It is like your favorite number is this much. Okay, so and down below you see this, your favorite number is unwrap or 42. For example, you did not give any favorite number because you have no favorite number. In that case, that by default we are telling to give the default value 42 by extracting 42. Just mention that 42 is a favorite number. Okay, but for now we are giving passing 3. It will just say that the favorite number is 3 only. So let me execute this. Your favorite number is 3. It's a good choice, and at the end, since we have already passed a known favorite number, so it is giving 3 only. So your favorite number is 3. So okay, let's say instead of this you are using like none case. Okay, and execute this. You don't have favorite number, what, like then it is fall back into this particular default case. Okay, so this is very very important, and in the coming videos we are going to this particular enum, okay, for error handling purpose. Okay, this is about the option enum. Okay, and now let's discuss about another inbuilt enum, which is result enum. Okay, for now I will comment this in the main code, and I will uncomment the this one. Okay, so now like this is like demo using the like result enum. This is also like a standard Rust enum. So this syntax is looks like this. We will pass, one is a value, another one is a error. Okay, so in this let's take we see here enum result of t comma e. You are passing two values. If it is true, okay, it will go into the pass case. If it is error, it goes into the error case. Okay, so now let's take for example, we are taking one string like s is a string. We are parsing from the main function. We wanted to parse from string to the integer. Okay, so here s is a string. Here we have given like s dot parse into I32. So if it is able to parse into the I32 value, then it will go into the OK, and it will parse the value, and it will print. Otherwise it will goes into the error case, like error parse string I32, like it cannot parse the given value. Okay, now and also similarly we have like unwrapping. So like the value passed from the main function to this one is a not a string, like it is not a parsable string from, not, it's not parsable from string to integer. It will fall back into this particular case. If this is also not a string, not a parsable string, then it will give -1. Okay, so in the few seconds I will explain all these things. And if you see from the main function, we are parsing 1 2 3 4 5 as a string, and we are going to parse that one into the I32. Let's execute this and see what happens. Parse its string as I32 1 2 3 4 5, because this is what we are sending from the main function. It should be able to parse, and it is also able to parse this 1964 also into a good string. Okay, let's say for example, from this you are, instead of 1 2 3 5, you are passing something like hello. So hello, can it be parsed into the integer? Let's check. Yeah, you see this error, parsing string as I32. so it is not able to parse it in I32, and the E is printing the error, whatever it is, invalid digit found in the string. But the default case is able to parse because it is 1964. Even if you change this one into a world, so it will return -1. You see this. So because the world it is not able to parse, it is returning simply not able to unwrap it. See, you see this condition, unwrap or -1. If you're able to unwrap the 964 as integer, you can unwrap it, otherwise fall back into the case -1. Since I have passed instead of the number we have given the string, it cannot be able to parse this, so it is like a -1. Okay, so it is like error case, right? So if the expected value is instead of but this particular number, if you are passing anything other than the number parsable string, you should, if you wanted to halt the entire application, there are a lot of other methods that you can follow. Okay, one of the thing is like expect. If I will, let me uncomment this code. We are giving like 1964 as a string, and we are trying to parse it as I32, and we are expecting if it is not that one, it is invalid here, and it will completely halts the execution of the program. Let me now execute and show you. Red main panicked at invalid here. It is giving the line number also at 108. This is like very useful one. So it mentioned the line number, so it's like kind of invalid digit that we are going to parse, and the complete execution is also now got stopped. Earlier it was just saying that it is error is occurred, but it is not actually doing anything, right? It is simply saying like error is occurred, but it did not halt any program. But if you wanted to halt the program, we have these kind of things like expect and other things. Okay, so with this we have completed the enums. I hope it's useful, and this is very important concept. That's why we are discussing right after the flow control. Coming, we are going to discuss about the like arrays and tuples, and also vectors and hash maps. These things, for there actually it is like a very important topic to be discussed. It's like a prerequisite for error handling. So you will going further, you will understand. So that yeah, if you like the video, please subscribe and share it with your friends, whoever is interested in the Rust programming language. And also I will upload this code in the GitHub. Thank you for watching.